Hello friends, this video on Gravitation Part 16 is brought to you by examfear.com. No more fear from exam. Please make sure that you have watched all the videos from Part 1 to 15 before going ahead with Part 16. Study Earth satellites. What is an Earth satellite? Any object revolving around the Earth is termed as Earth satellite. For that matter, when we talk of the term satellite, it would mean any object which is revolving around a planet. So when I say Earth satellite, it would mean objects revolving around the Earth. Now we can classify satellites into two types. One is natural satellite, the other one is artificial satellite. So here we'll see what is a natural satellite. Natural satellite is a satellite which existed already in nature on its own. That means nobody had to put in any efforts to discover that satellite. It was already there on its own. So the only natural satellite which Earth has is Moon. So Moon is the only natural Earth satellite which existed on its own and which revolves around the Earth. Now let us have a look at artificial satellite. So artificial satellites are human-built objects orbiting the Earth for practical uses. So this means that human beings develop certain kind of objects which are capable of revolving around the Earth. Now, when human beings take so much of pain in developing such artificial satellites, so obviously they have certain practical purposes because of which they are built. So there are several purposes which these artificial satellites serve. We will see that. So it is something like this. Let us suppose if this is an artificial satellite, it revolves around the Earth in a fixed orbit. So there are various uses of artificial satellites, like it is used for communication, for television broadcasts, weather observation, military support when needed, navigation, and scientific research, of course. So because of so many different purposes, different artificial satellites are built by human beings. So till now we saw what is an Earth satellite, what are the two types of Earth satellites, natural and artificial. Now we will go ahead and we'll see how to determine the time period of an Earth satellite. So we will try to get an expression for determining the time period, that is the time a satellite takes to complete one rotation around the Earth. Let us suppose this is the Earth and we have a satellite which revolves around the Earth in a circular orbit. So in this case, since it moves in a circular orbit, there would be a centripetal force which would be acting on it. Now what would be the centripetal force? This centripetal force will be mv square divided by r. What will be r? R will be nothing but re plus h. H would be the distance of the satellite from the surface of the Earth, because re is the radius of the Earth. Now the satellite would be somewhere at some point, say this. So this distance will again be h. So the entire distance would become re plus h, right? So this centripetal force will act towards the center. Fine. Now there would be another gravitational force which would act between the satellite and the Earth. So that will be given by g into m, that is mass of the satellite, capital Me, that is mass of the Earth, divided by re plus h whole square. Now this is the force which will balance the centripetal force Fc. So therefore these two forces should be equal, that is Fc should be equal to Fg. Now let us equate both the forces. So it will become mv square divided by re plus h is equal to gm me divided by r plus h whole square. Right? So this re plus h and this re plus h will get cancelled. This m and this m will also get cancelled. So we get v square is equal to g me divided by re plus h. So we get from this V is equal to root over GME divided by RE plus h. So this would be the velocity with which the satellite would be revolving around the Earth. So this would be the velocity. Now we want to calculate the time period, right? So we will do that. Now we know that the satellite would cover 2 pi RE plus h, that is the circumference, right? 2 pi RE plus h distance with speed v, which we calculated just now. Therefore, the time period would be equal to 2 pi RE plus h, that is the total distance travelled, divided by the velocity v. So this will be equal to 2 pi RE plus h divided by root over GME into root over RE plus h. I have just put the value of v from the previous equation which we got in the previous slide. Therefore, value of t comes out to be 2 pi RE plus h to the power 3 by 2 divided by root over GME. So this is nothing but the time period of a satellite which revolves around the Earth. So this is how we calculate the velocity of a satellite with which it revolves around the Earth, as well as the time period of the satellite with which it orbits around the Earth. Now we will also consider a special case of this. So we will see a special case. A special case when h, that is the height which we considered, like if suppose this is the Earth and this is your satellite, so this is radius of the Earth and this distance is h. If we say that h is very less than RE, what will happen in that case? In that case, RE plus h can be approximated to RE because h is very small when compared to RE. So t will be equal to 2 pi root over RE cube divided by GME. Now this we can write in terms of acceleration due to gravity as root over RE divided by G, because G is equal to GME by RE square. So using that we can write this. So this will become the time period in case h is very less than RE. That means if this satellite is very close to the surface of the Earth. So in that case we will arrive at this solution. So you saw how do we calculate the time period for a satellite as well as the velocity with which the satellite moves around the planet. Now we'll go ahead and we'll see the energy of an orbiting satellite. Now we will find out an expression to evaluate the energy of an orbiting satellite. Before this we saw how to calculate the time period and velocity of a satellite which is orbiting around the Earth. Now we will see how do we evaluate the energy of an orbiting satellite. Now let us suppose that for the satellite we consider that m is the mass of the satellite and the velocity with which it is moving around the Earth is v. So m is mass, velocity is v. So what would be the kinetic energy of the satellite? It would be half mv square. Now we have already found out the value of v just in the previous topic. So v is nothing but gme divided by re plus h. So we get the kinetic energy as half m gme divided by re plus h. Now let us calculate the potential energy. So what would be the potential energy? It would be minus gme into m divided by re plus h. Now if you see the values of kinetic energy and potential energy, you can find out the total value of energy, that is total energy is nothing but kinetic energy plus potential energy. So if you calculate that, it is half mg into me divided by re plus h plus minus gme. So plus minus would be minus. So minus gme into m divided by re plus h. So this comes out to be minus gme into m divided by re plus h. So this is the value of total energy, right? So what do we observe from this? We observe the conclusion. First conclusion is we found that potential energy is equal to twice the value of kinetic energy. If you see the value of potential energy, you can very clearly see that half of potential energy is kinetic energy, right? And what is the second conclusion? The total energy is negative. So that means, when the total energy is negative, that means the system is a bound system. That means the system cannot escape. So this shows that this is our Earth, let us suppose, and this is the satellite. Since the total energy is negative, therefore the satellite is bound to this Earth satellite system and it is moving in this fashion. Otherwise, it would have just escaped from the attraction pull of the Earth and it would have not moved in a particular orbit. So this also indicates from the fact that total energy has a negative sign. Now we'll go ahead and look at certain problems regarding all the topics which we have studied so far. Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.